All right, we're going to continue our lecture on goals for primary math. The first goal was to lay a solid foundation in what? Basic concepts, basic skills, and we dealt with our number concepts, our basic arithmetic skills, and measurements. Let's go to the second goal. As a primary teacher, remember, we've talked about this. What's our theme? We always teach from scratch. And that's because we're laying a foundation. So quite possibly the primary grades, well, not more than quite possibly, the primary grades are going to be foundational. That makes them very, very important. And so we're going to lay a solid foundation by the time third grade is done. Okay, we have basic concepts and basic skills that have to be mastered. Then the second thing that we're going to do, our second overall goal for primary math, is to pave the way for expansion. Pave the way for expansion. Let's go back to and review again our 7 steps. We have terminology. What's after terminology? Facts. Next, concept. Next, procedure. Then, expansion. Then, problem areas. And last, everybody's favorite, story problems, which are? Right, their application. All right, so in our goals, we want to lay a solid foundation, and that's this idea here. With the teaching math classes, we have teaching elementary first semester, right? And then second semester, you were allowed to pick teaching primary or teaching intermediate. And part here of this goal has to do with an idea that I think is important for you to realize. Elementary math, the center grades of elementary, third grade, fourth grade, fifth grade, right there in the middle, those classes, they've already got a lot of their foundation if you've done your job as the primary teacher. So with the 3 divisions of this class, we had teaching primary, teaching elementary, teaching intermediate, correct? So primary, what's our focus? Solid foundation. And then our second goal is we're going to pave the way to do what? Expand. Okay, so what if I draw a line right here, and as a primary math teacher, you have to lay the foundation up here. You're the one teaching them all the addition families, right? You're the one teaching them add in sum, minuend, subtrahend, diff, all the terminology. And you are having to do our first goal, lay a solid foundation in both number concepts, basic math skills, right? And now our next goal is you're going to pave the way for expansion. What does the elementary teacher do that's beyond primary? The third grade teacher, the fourth grade teacher, the fifth grade teacher. They're learning a lot of procedure that are an expansion of what you did in first grade, second grade. So here's our goal. We want to pave the way to expand the basic arithmetic skills. So what are we doing here? We're paving the way so the fourth grade teacher can expand on procedure after procedure. And if you do your job right, let's go to this guy. If you do your job right, there's going to be fewer problem areas for the second grade teacher, if you're the first grade teacher, for the third grade teacher, and so on. So you want to not create problems for next year's teacher, or the following year's teacher, or for me, the high school teacher. Okay, and so this is what I mean by our second goal. Pave the way to expand the basic arithmetic skills. Okay, that's our second goal. As a primary teacher, we have to, what did we say about concept? Success is understanding, right? So I want you to remember that. Success in mathematics is understanding, and by that I mean understanding concept. So what's your job as a first grade math teacher? Reaching their understanding of basic concepts, reaching their understanding of place value, and that's my first point. We are going to pave the way to expand our basic math skills. First of all, place value. Place value. We want to expand place value beyond the thousands place into learning the thousands period, learning the millions period, and so forth. And what's that based on? If I'm going to expand, I'm paving the way to expand my place value. What do I have to do? I have to understand the concept. What is the concept of place value that I'm expanding? And that's the idea of periods. First and second grade math, they work almost exclusively in the units period. Ones, tens, hundreds. Why is that period called the units period? Because those same three repeat, remember? In our bigger, let's take the number 415. Ones place, tens place, hundreds place. In primary math, we do start doing thousands, and that's kind of where we stop. We don't do much more than 4 digits. As a matter of fact, in common arithmetic procedure today, we don't even use the comma. We start using the comma after we get to the 10,000s place. So what I'm doing, I'm paving the way to expand place value now, beyond the thousands place. Primary students are stuck in the units period. Okay, and then we're going to be progressing to the thousands period, the millions period, really not beyond that. Back to my question, why is this called the units period? Why is it called the units period? Because ones, tens, hundreds repeat 1,000, 10,000, 100,000, 1 million, 10 millions place, 100 millions. Those same three basic units, basic places, those same three basic places, hundreds, tens, ones, repeat in each period. What's the key to being able to read my large number? It's taking the period as it stands alone, right? Say its name, go to the next period, as it stands alone, say its name, and then just say the number in the units period. So this is 12 as it stands alone. So 12, then the period name, million. So 12 million. Then we read this number as it stands alone. What is that number as it stands alone? 983, 983, what? Thousandths. So 12 million, 983 thousandths, 415. No ands allowed. What is and reserved for? Decimal point. So don't use it in primary. We don't say 415. Do not say and. You're the primary teacher. You are not allowed to establish bad habits, are you? Okay, so we want to pave the way to expand basic arithmetic skills. So beginning with place value, we want to pave the way to expand place value beyond the thousands place. This involves, first of all, understanding the units period. We have to understand that the units period, ones, tens, hundreds, repeats in each period, and then we learn the periods. So we want to establish that. So we need to understand the units period. And secondly, we want to establish good habits with reading our numbers. I don't have any zeros in there, but I'm like you. I say 105. Is that 105? No, it's not a room number. Maybe that's where we get it. But in common English usage, I guess we could call it that, we say 105. I say that all the time too. If it's five minutes after 1, I sometimes will say 105. Or if I'm talking about room 108, I'm going to say 108. So the first thing, understand our units period. Secondly, avoid bad habits in reading and writing numbers. 105, no, 0 is not an O. How do you read that? 105. Don't even say and. Don't say O. It's not an O, it's a 0. Okay, on your keyboard, is there a difference between the 0 and the O? It looks different. It is different. Don't interchange 0 and the letter O. You don't interchange them on your keyboard. Don't interchange them with your tongue. So we want to establish good habits. Okay, otherwise we can't expand. I've taught 5th grade math a few times, and I'm teaching 7th grade math, as you know, and I often have trouble with rounding behind the decimal. I can't expand it because it's not understood. So do you understand what I'm saying here with this goal? Your goal for primary math, first and foremost, is to lay that foundation. And secondly, you want to pave the way. So that's why you have to have math skills beyond theirs, obviously, but also you need to think about it. Think about it. Now I'm coming at this class from the other side of it, so I have a different perspective than Mrs. Brader and then Miss Mayville. That's why they're going to be in here, because their perspective is they're coming from the primary up, I'm coming from the intermediate down, and we both have different perspectives and different spins that we can put on this class. And my spin is, you're expanding for me, you better do a good job. Okay, but as far as the students go, you want to be careful with your place value so you're not establishing bad habits. And the third thing is, you're not propagating myths. This is bad in primary science, but we won't go there today. Okay, propagating myths. Okay, if you've taken biological issues, you know one of the myths that I have to dispel about the digestive system is that the stomach digests food. Guess what? Very little digestion occurs at the stomach. Where does digestion occur? Small intestine. That's a myth propagated by elementary science teachers. Okay? That's just an illustration. Can we apply that to math? I guess it wouldn't be myths. You're propagating misunderstanding. That's what I mean by myth. Now in science, I do mean myth, but you don't want to propagate misunderstandings that are going to cause them confusion when they need to learn to do that concept. So we are paving the way. Do you get the idea of these goals? You're laying a foundation, you're paving the way. Okay, so you want to pave the way to expand the students' basic arithmetic skills, beginning with place value. Right, so you have to understand the units period and how it's going to be used and how it's going to be expanded. You have to not allow and start bad habits like reading 105. You have to not propagate misunderstandings. A lot of that takes place with rounding. Rounding is a skill involving place value. The rounding rules can be applied. Why am I having trouble applying the rounding rules behind the decimal? It doesn't make any sense to me because they're identical. I'm just changing the places. I think that comes back to we haven't paved the way for rounding. You always find the place, look at the next door neighbor, and round up or drop. Okay? All right, so we want to pave the way to expand your students' basic arithmetic skills, first of all, beginning with place value. With place value, you have to understand the units period. You don't want to allow any bad habits to be established, and you don't want to propagate misunderstanding, propagate myths. All right, and one area that you will need to expand is rounding. So basically, what are the things that we're expanding with place value? We're expanding in two ways. We're expanding beyond the thousands place, and we're applying our rounding rules wherever. Okay? whether it's rounding to the hundred thousandths place, is done the same way that we round to the hundredths place. We look at the next door neighbor and we round up. Uh-oh, we have a 9 here. What happens? We have to go all the way to 13 million, don't we? That's a quirk, and we need to address those quirks with the 9, but we don't want to base our teaching on a quirk, okay? Then we will expand rounding, we will expand reading to bigger numbers, and then rounding wherever, including back here. A 5th grade teacher has to expand place value behind the decimal point, and we want to pave the way. The 5th grade teacher has to expand the rounding rules behind the decimal, and we want to pave the way for that. Keep in mind where your students are headed. That's what I want you to think about on this goal. You want to keep in mind where your students are headed. All right, let's go to the next thing, addition. So in this goal, we are expanding addition. What are the, with addition, what is the terminology? The numbers are called add-ins. The numbers being added are called add-ins. The answer is the sum. Okay, so terminology paves the way to understanding that the order of the add-ins does not affect the sum. That is the formal property called the commutative property of addition. Obviously, Tamar's not going to teach the 1st graders about the commutative property of addition. Let me say Mrs. Brader, but she does teach it. She doesn't call it by its name, but she does teach it. So I have these things in mind. My goal is to pave the way for the commutative property. I'm not going to teach the commutative property. What am I doing as the primary teacher? What am I doing even as the elementary teacher? What am I doing as the intermediate teacher? I'm still doing it. Even if I'm not primary, I'm still paving the way for the next year in math, for the next level in math, okay? So pave the way for next year and next year and next year. So terminology, I'm paving the way to expand terminology from, you know, my flashcard in 1st grade. Add in, sum. What am I doing? I'm paving the way. Then when I pull out my subtraction, we have to learn 3. We have to learn minuend, subtrahend, difference. Can I move my minuend and subtrahend? That's why they have their own name. Okay? So I'm paving the way in terminology. Add in, sum. Why do the add-ins not have their own name? Because which one is which doesn't matter. I'm paving the way. So when my 1st graders see this, there will be several of them that notice that both the answers are 5. That's the commutative property of addition. I'm going into a lot of detail here because I want you to get the mindset not only of laying a solid foundation, but of paving the way. Okay? So I'm paving the way for my students to be successful in addition. The first thing is terminology. Facts. I just told you a minute or so ago, who's teaching them the addition families? Who's teaching them the subtraction families? We're dealing with addition. Who's teaching them the addition families? You are. So what do you need to do? You need to make sure that they are, what's the word? What's the word here? Automatic. So you're paving the way. You're paving the way for their expansion into doing multiple long column addition. Can they be successful in long column addition if they don't know their addition facts? No. Okay, then they're going to be tripping over it constantly, and they're going to be missing the problem when they start doing the multi-step procedures. That's frustrating. The problem's just as wrong when I don't know the procedure as when I make a dumb math error in my math fact. Okay? So I'm paving the way in terminology. I'm paving the way in addition by making sure my first graders know their addition families to wherever I need, especially second grade. And remember, go back up to your first goal. What did we say? By the time we're done with third grade, they should not have any trouble with their addition facts. Should they? All right, concept. Concept has the idea of what is addition? What is addition? Plus, altogether, total. So where do we begin with addition? We have to learn the key words. We have to learn that this is done with manipulatives. And this is very primary. This is first grade for beginning. So I learned to what addition is. That's kind of arbitrary. So I'm going to anchor it in reality using manipulatives. And that's kind of related to counting. However, just like with place value, are you going to establish bad habits? Okay, I don't even know how to do it, counting on their fingers or whatever. No, so we do start with manipulatives and we transition to memorization of those addition facts, so then we can apply them to the procedure of start doing our long column addition, start doing our carrying. So we are paving the way to expand the basic math skills. All of these. We have to understand what addition is and all of its key words. More than, altogether, total, of course, sum, plus. And that's done beginning with manipulatives early on. And then we will go to procedure. What's the key procedure to have mastered so that it can be expanded? Would be carrying, right? So we are going to make sure that we can carry. Why? We have to expand it. We start with carrying from the ones to the tens. And then we have to carry from the tens to the hundreds. And actually we're carrying tens all the time. And it doesn't matter if it's between the ones to the tens or the tens to the hundreds, etc. So we have to make sure that we're not going to have carrying issues. So we want to pave the way to expand what addition is, your addition families, and addition procedures. And keep in mind, all of these things are going to be expanded. Along with concept, we can't forget the law. Surely by now you know my law. What's the law of addition? And we did this with measurements, much more so than addition. We can't really do it with addition because in primary we're just adding numbers. We're adding whole numbers. But we're going to have to cover it later with measurements. What is the law? What's the law of addition? You can only what? Add likes. So we do have to put that in as well. So what is addition? And then the law of addition. As the algebra teacher, I'm still in 9th grade using the law of addition. Can I add 3x plus 4y? No, they're not likes. Can I add 4 feet plus 10 inches? No, they're not likes. So we're going to be paving the way with addition, and then we're going to pave the way with subtraction. This will go a little faster because it's the same idea. We're going to pave the way with our subtraction terminology. As mentioned, we cannot change around the order of our subtraction problem. Subtraction is not commutative. And that begins with the terminology, minuend, subtrahend, difference. With subtraction, we're going to have to spend a little more time paving the way with concept of what subtraction is. Takeaway. And this begins just like addition, but even more important than addition is with the manipulatives. And back to here too, who's teaching them the subtraction families? You are, okay? So I have to get the concept down of what subtraction is. Then I also have to, with concept, I do have to link it to addition. It's the opposite of addition. Second graders do equations. They don't use variables, but they do equations. 3 plus what equals 8? What goes in the blank? A 5. In reality, how did you find that? You subtracted 8 minus 3. So we will start doing things like this. Guess what you're doing? You're paving the way to solve equations. So we do want to get down the idea that subtraction is the opposite of addition. So when I need to find an add-in, what do? Subtract. Okay? All of these little things that you might see in your curriculum, you might think, I don't have time for that. I'm going to skip it. Please don't. You might have to skip some things. It's not possible to cover everything. It's not possible to get everything down. But be very careful about what you skip in your curriculum and what you center in on your curriculum. And if you have this idea in mind, you're going to pave the way. You might think, why do they need to know that? Well, make sure you investigate it. It may be very important. So you're paving the way. In algebra, we know that addition and subtraction are inverse operations. And in fact, by the time we get to algebra, we don't need subtraction as a separate operation anymore. We have negative numbers. And so we add opposites instead of subtracting. All of that is years and years down the road. But we're going to pave the way and make it part of our understanding. And this can be a game. Most of them, if they know their facts, they're not going to actually think that they're doing 8 minus 3. Their brain should do it all by itself. Because how many times have they seen a similar flashcard? I could even, to jog their brain, I could even put it like this. I can do it with my flashcard. My flashcards have the answers on the back, especially if I have a nice Abeka set. What do? You cover the answer and you start sharpening their minds mentally. Think about yourself. How nice would it have been if you had all these little extras? Okay, your math skills would be better, and so on. So all these things keep in mind. And you can make a game with finding the missing number. And what are you doing? You're making math fun, which is not as important as paving the way for algebra. Okay? And so math class can be the funnest time of the day. And then we can even use our fun to pave the way for what we know is coming later. So subtraction. The first thing we're going to do, obviously we do the terminology. We do teach them we're the one teaching them their subtraction families, but concept is beyond just learning what subtraction is. We're paving the way for the future. Subtraction is the opposite operation of addition. It's correctly said that it's the inverse operation of addition. All right, what's the procedure? We have to master is borrowing. That's not as directly applicable to this goal, but it has to be mastered. Multiplication. We are paving the way. Where's multiplication really take off? Grade 3. So between the end of second grade, beginning of third grade, and by the time we get to the end of third grade, we have to understand multiplication. We'll begin with terminology. there's two ways we can name. We can use multiplicand times multiplier. This has kind of been abandoned more and more, and I'm glad, because I'm the intermediate math teacher, I'm the Algebra 1 teacher. Is there any need to distinguish between the top and bottom number in our multiplication problem? Why not? Because like addition, multiplication is commutative. So we need to concentrate on the word factor. Factor times factor equals product. Multiplication is a big expansion for you as the primary teacher. Multiplication, beginning with its terminology. Down the road, we have to learn this. Greatest common factor. We should already know what a factor is because we always used factor in our terminology. We also have to distinguish between least common multiple versus greatest common factor. Remember, if we have 3 times 4 equals 12, 3 and 4 are the what of 12? We're talking terminology. They're the factors of 12. What is 12? 12 is a multiple of 4 and a multiple of 3. What are we doing? Paving the way for the 4th grade teacher who has to teach them how to reduce fractions, who has to teach them how to find a common denominator. So we are conscious of the fact that everything we do in primary math is going to have a result. Okay, if we are careless with our terminology, we're not going to be paving the way. So factor times factor equals product. So when I'm teaching and when I'm asking questions, I don't say what times 4. I don't use vague words like what's the answer or what number. This isn't a number. What is it? It's a factor. It's a factor. Because it's in this multiplication problem, it's not just a number, it is a factor. What is 12? It's the product, right? And it's also multiples of its factors. So why is it that 7th graders don't know what factors are? They're not used to the terminology. They're used to saying what number. No, what factor. Or what product, or what is the sum, what is the minuend. I tell them never bring down the subtrahend. Well, that's a worthless statement when they're not used to always thinking of the subtrahend as being the number subtracted. If we go back to terminology, think about it, you're paving the way for later so that we can do what? Avoid problem areas. Okay, so we can avoid confusing greatest common factor and least common multiple. Everybody confuses those two. So we want to do our best in every aspect. Okay, so with multiplication, terminology. Terminology. Use it. Isn't that what we said? Every time we go through these 7 steps, use them. Use the steps and use the terminology. All right, with multiplication, we have to use the proper multiplication terminology. Factor times factor equals product, and the product is a multiple of its factors. Right? Facts. Who's teaching the times tables? Grade 3. Grade 2 is going to be understanding what multiplication is. Grade 3, we've got to have our times tables really well done by the time we're done with 3rd grade. Not as much as the addition and subtraction facts, but if we have our multiplication tables down pat for our 4th grade teacher, then the 4th grade teacher can really concentrate on her main goal, which is fractions. Okay? We want to pretty much have our whole numbers down pat, by the time we get to the end of 3rd grade. Okay, even the division, because guess what? We'll get to division in a minute. Let's keep going with multiplication. All right, so multiplication, concept. What is multiplication? Anybody know? That's correct. It's repeated addition. Multiplication is repeated addition. This is going to be expanded by me in Algebra 1 and also in 7th grade math. How am I going to expand this? Well, in algebra, there are only 3 basic operations. Addition. I'm showing you this because I want you to have a mindset. I want you to have a goal as a primary teacher of doing what? Basic foundation. You're pouring it. Remember, we said that before. You're pouring the foundation. And now our second goal is that you are paving the way. You're paving the way for me to transition intermediate students from arithmetic to algebra. You say, I'm only teaching 1st grade, that's 9th grade, that's 7th grade. I've got 6, 7, 8 years. No, we're paving the way for expansion. We're paving the way to avoid problem areas. We're paving the way so that the 7th grader doesn't say, I'm not good at math. And then I hear their parents say, I've never been any good at math. That's why, you know, so-and-so isn't good at math either. What do you mean you've never been good at math? Let's teach students math so we don't hear anymore, I'm not good at math. Okay? It's the math phobia. Usually it's in the form of fraction phobia. But let's not start math phobia. All right, so what is multiplication? It's repeated addition. Instead of writing 3 plus 3 plus 3 plus 3, I just do 1, 2, 3. There's 4 3s. So I'm going to do 4 times 3. What do I get? 12. Well, I'm going to expand this. In algebra, there's only 3 basic operations. Addition, multiplication, and exponents. Also called powers, like squaring, 2nd power, cubing, which is 3rd power, 4th power, 5th power, 6th power. Addition is a basic operation, multiplication, and exponents. There's no subtraction because we have negative numbers. There's no multiplication because we have reciprocals. And exponents is an entirely different animal altogether because what is an exponent? It's repeated multiplication. There's where I was going. Multiplication is repeated addition. Exponents represent repeated what? Multiplication. This is 3 to the 4th power, which is 81, not 12. Okay? So all of math is building. I always slam history. I was slamming it yesterday in Algebra 1, saying this isn't history where we have our test on the Civil War and I'm done with it. No, you have to retain some of, we're doing radicals. You have to retain some of the square rooting that we did in Chapter 11 because this is Chapter 12. Okay, we can't, it's not, okay, divided into periods. Civil War, post-Civil War, you know, the great, I don't know my history, so I'll stop. But what are we doing? We're paving the way for expansion. We're building a foundation, especially in a subject area as mathematics is. Okay, so what is multiplication? It's repeated addition. And for me, as algebra teacher, as intermediate teacher, that goes steps right into what an exponent is. Multiplication is to addition as exponents are to multiplication. It all fits together. It all expands and builds on principles below it. And guess where you are? You are the foundation. So you want to pave the way to expand multiplication. So you do have to teach and center in on the fact that multiplication is a shortcut to addition. It replaces repeated addition. And then you are teaching them the times tables. Okay? And how do we teach the times tables? How do we teach repeated addition? So multiplication is repeated addition. We just saw that. So if multiplication is repeated addition, how do we teach that? What do we tether it to? No. Let me back up. As the primary teacher, you're not doing a lot of tethering. You're pouring the foundation rather than attaching to it. But in this case, we are going to be tethering this to something that we did with our number concepts. Counting. Here's the illustration I just erased. Okay, how can I get to 12? Counting by threes is the precursor to the 3 times tables. All right, I chose 3 because 2 can be a little confusing because it's even. And the problem with using 2 is 2 times 2 is the same as 2 plus 2 is the same as 2 squared. So we stay away from 2s when you're using illustrations. But how do we get here? What? 3, 6, 9, 12. Okay? So then that way we tether that to reciting no zeros. Okay, 0 doesn't count with counting. But that was a brilliant statement. 0 doesn't count with counting. It doesn't. So we do 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, because if I was counting, we do a lot of counting bys. So we will tether it to counting. If I'm teaching the 3 times tables, I tether it to counting by 3s. Basically, multiplication is taught at the end of 2nd grade. 2nd semester, 2nd grade, through counting. And then if we do 0, the 0 times tables, we have to teach about the principle of 0. Any number times 0 is 0. We also have to teach about 1. But when we start expanding into the 2 times tables, the 3 times tables, the 5 times tables, then we go back and pick up the 4s because we don't usually count by 4s. And the 10 times tables, we will tether it to counting. So multiplication, what is multiplication? How do we teach multiplication? By manipulatives and by teaching it based on counting by 3s, counting by 2s, I guess would be the best place to begin. All right, then one more multiplication concept. Multiplication is not limited to likes, so there is no multiplication law. So we're not going to teach that there's no multiplication law, we're just going to be aware of it. All right, then, procedure. The procedure is going to be carrying, and it involves the partial products, as we've mentioned before. You're going to be teaching carrying as related to addition. You're going to have to teach the partial products. This is 3rd grade. So you will be expanding for partial products. As the 3rd grade teacher, guess what you're teaching from scratch? Partial products. Carrying will be taught by the 2nd grade and will be tethered to carrying in addition. All right, so we are paving the way in our basic arithmetic skills. We're going to pave the way to expand our place value. We're going to pave the way with addition, subtraction, multiplication, now division. Of course, we're going to introduce the division terminology. And we will be teaching division, but division is, I'm going to skip kind of down and center more on division concept. Okay, yes, we have dividend, divisor, and the answer is the quotient. Yes, we teach it and so forth, and we will teach the division, but I think I've told you before that division is so closely tied to multiplication that it's not really memorized separately. Like the multiplication times tables have to be memorized separately. Even addition and subtraction is somewhat like that. We memorize the addition and then relate the subtraction to it. But basically we're going to memorize the addition and the subtraction families. That doesn't work as much, and it's not done as much with multiplication and division. Multiplication, if we memorize those multiplication times tables, the division follows logically, much more so than addition and subtraction. So we're going to center in on concept. Division is the inverse operation. I'm not going to use opposite because that's the wrong word. That's going to propagate a myth. Okay? Opposite is reserved for signs and addition versus subtraction. Inverse. It inverses, it's the idea of reversing. It's the inverse operation. I keep wanting to say opposite and I'm deliberately avoiding it. Okay, it's not technically the opposite operation, it is the inverse operation, and that's why we teach those two simultaneously. Multiplication tables and division facts are simultaneous, because one of the most important concepts about division is that it is the inverse operation. Because when we're teaching division, what is division? Okay, I can hardly even think of how to say it without using the word divide. Okay, and so we have to tether it to multiplication. So division is the inverse operation, because we're going to teach division with this little phrase. And then we're going to goes into, right? So division is much more closely tethered to multiplication than subtraction is to addition. So division is the inverse operation of multiplication. We're going to think what times. I even have to go back to this in algebra. We'll be doing polynomial division, and we set it up as long division, and it has the same steps as arithmetic long division, and we'll be doing something like this. I'll just throw some things in here. And I'll ask them, and they'll look at me like, oh no, what does she want? And I always have to revert to what times x equals 3x squared, and then they can get it. It's 3x, because 3x times x is x squared. I even have to go back to the what times little phrase. And then x goes into 3x. They even have trouble with goes into. I'll say, what is, how many times does x go into 3x squared? And then they can get 3x. But if I say goes into, they look at me like I have two heads. Okay? But, so we have to address this. This is primary. We're going to introduce division in primary math because it's so closely tethered to multiplication, we can hardly introduce one without the other. So we're not going to really get division down, not the long division. When I say division, you're thinking long division. That's not really going to be conquered until third grade, fourth grade. Definitely fourth grade. Fifth grade really solidifies the long division and does the decimal long division, the kind of division that we don't like. All right, but what are we doing, especially with division? We don't really teach it and master it in and of itself in primary. We are really paving the way for division altogether. This is a whole paving the way. Second grade just paves the way for division. They really don't do it. Okay, so division. Pave the way for division. Pave the way for division. And so with division, concept-wise, we are going to really just introduce it as what times, and then goes into. And then we can say 15 divided by 3 equals 5. But we have to start with 3 goes into 15. We'll be doing this in second grade. Okay, and so we're not going to say, how many times does 3 go into 15? We're going to have to say, what times? Okay, what times 3 equals 15? And the answer is 5. If I ask them goes into, they won't get it. I have to teach them and then transition from what times into goes into. And then I can say divided by. Okay, so I am paving the way. That's about all I'm doing with division. Procedure, I have to teach them to set up division. I have to teach them who's the dividend and who's the divisor. But I'm not doing long division till third grade. And even then, I'm not doing very much. Fourth grade, and then fifth grade is where we start the estimation. So my whole division of primary math is pretty much all paving the way. We'll expand it into long division in grade 3, 4, and 5. All right, so the last thing we're going to pave the way with is fractions. Fractions, okay? Fractions, what are we going to do? With fractions, we are going to... Anything here? So we are paving the way, first of all, with place value. Secondly, we're paving the way with basic operations, addition, subtraction, multiplication, and division. The last thing we're paving the way for is fractions. All we're going to do is set a foundation of what are fractions. All we're going to do is set a foundation of terminology. The top number is called the numerator. The bottom number is called the denominator. We're not going to do a whole lot more than that. We're going to be having equal parts. What are fraction? Part of a whole. So everything we're doing with fractions is paving the way. All right. Next time we will pick up with the third and the fourth goal, which is establishing good habits and developing an appreciation for learning.